I am Anil Kumar. Welcome to my series on polynomials. Here is exam practice for polynomial graph. We'll consider cubic and quartic functions. Question number 1 here is factorize and sketch the graph of the following functions. Indicate coordinate points where the curve crosses the axis. A. Y equals to 3x minus 12x cubed. B. 2 minus x whole cube minus 1. C. Y equals to x minus 3 whole square times x plus 1 whole square, and D is 2x plus 1 times x square minus 7x plus 6. You may need to only factorize part A and part D. Now part B could be done with transformations, right? C is already factored for you, so you don't have to factorize that one. Question number 2 here is the graph of y equals to ax cubed plus bx squared plus cx plus d is shown in the figure. Find the values of a, b, c, d I should have mentioned, so also a, right? So a, b, c, and d. You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the solutions. We'll begin with 1a, which is factorize and sketch the graph of the following function. You need to indicate coordinate points where the graph crosses the axis. So the function given to us is y equals to 3x minus 12x cubed. It is always better to write the highest degree first, right? So it is minus 12x cubed plus 3x. The common factor is good to take minus also as a common factor, will be 3x with a negative sign. So that makes this as positive 4x squared, and here we get minus 1. Now this could be written as minus 3x. So that is difference of squares. We could write this as 2x plus 1 times 2x minus 1. So that is fully factored. Now it is easier to sketch the graph of this particular function. So we can begin with writing zeros. Zeros are at x equals to 0. This will give 0 at minus half, and that will give 0 at plus half. All these are linear zeros, right? So we are not writing double zero or cubic zeros. All are linear zeros here. We can find the value of the function at 0, which will be 0. So that is the y-intercept also. The end behavior. As x approaches, let's say negative infinity, in that case, what will happen to the graph? Well, the leading coefficient is negative, right? So the leading coefficient is negative. So y will approach positive infinity. The right side is going to be down. That is to say, when x approaches positive infinity, y will be going to negative infinity. So for that is because in this particular case, what do we have? We have an, the leading coefficient, which is less than 0. So write down, right? So right side is down. So what I'm trying to say here is that when you sketch the graph, let's say that is the x-axis and that's the y-axis. In that case, from the characteristics of end behavior, we know that the leading coefficient is negative. That means the right side is down and is going to start from the opposite end since it is a cubic function, correct? Now let's mark the x-intercepts which are at 0, plus and minus half. Let's say this is our minus half and that is plus half. Now in all these graphs which we are sketching, the important point to mark is actually the points where the graph is crossing the axis. That is to say, both x and y intercepts, correct? So these are very critical intercepts which should be clearly marked. Now they are all linear. That is to say that the graph will cross like a line along these. So I'm making these short lines indicating that when we sketch a smooth curve, crossing through these points, it should be linear in nature. So we could just now connect our curve with something like this. Do you see that? So that becomes the graph of the given function under the given conditions. Now here is a very important note about all these graphs which we are going to sketch. We are not sure about the turning points, right? So within given information, we are not really working out a turning point. Now that is a part of calculus. We'll learn derivatives and then do it, right? So later. So for now, we are restricting ourselves to the condition that x-intercepts are accurate, y-intercepts are accurate, but not the turning points, right? So I could have also sketched this graph, for example, in this fashion. That will also be correct. Perfect. So we are using only the intercepts to sketch our curve at present. Perfect. Second question here is, we need not have to factorize this, right? So we'll just sketch the graph, right? Since the equation is given in the vertex form, let me rewrite the equation, which is y equals to 2 minus x whole cube minus 1, right? So that becomes the equation. Now, how do you find x and y intercepts in this particular case? So as far as the x-intercept is concerned, x-intercept is when y equals to 0. So we'll equate y to 0 and find the x-intercept. Which is whole cube minus 1. So bringing 1 here, we get 2 minus x whole cube. And then cube root of 1 will be what? Cube root of 1 will be 1, right? So 1 equals to 2 minus x. So clearly, x is equals to 2 minus 1, which is 1. So the y-intercept in this particular case, rather x-intercept in this particular case is 1. Now let's find the y-intercept. Y-intercept is at x equals to 0. So y value will be 2 cube minus 1, which is 8 minus 1 as 7. So the y-intercept is at 7. You get the idea, right? So we got x and y intercepts for us. Now let's try to sketch this graph. So we are saying that the x-intercept is at 1. So this is the x-intercept, and y-intercept is somewhere there, right? Let's say 7, right? So approximately, I'm just placing the points here. Now, how do you really sketch this particular graph? I will actually use transformations. Correct? So we have y equals to 2 minus x whole cube minus 1. Now we could think about it as minus of x minus 2 whole cube minus 1. See, x should be written first. So that really means that the leading coefficient in this particular case is going to be negative, right? So left side up, right side down. You get the idea, right? So that is how it is going to be. The vertex, so normally, let's think about the transformations. So let me make a small sketch here to show you that normally the graph will be of a cubic function like this. Now it is reflected, so it is going to start from this side, right? So the behavior is that it is going from quadrant 2 to quadrant 4, correct? The point which was at the origin has been translated 2 units right and 1 unit down. So that point, which is the saddle point, has been translated to somewhere there. You get the idea, right? So basically the graph is coming down from here and then going like this. Perfect. That is how it is going to be. And this is the saddle point, which is at 2 minus 1. X-intercept being at 1, y-intercept at 7. Do you see that part? So we have done this with transformations. So remember, if you are given in vertex form, we have applied the transformations. The transformations here are reflection. First is the reflection on this negative, right? So on the x-axis. Second is we have to translate 2 units right and 1 unit down. Is that clear to you? That is how we are going to sketch this particular graph. So it's kind of very different from what you've learned in this unit. Get the point? You have to use the concepts of transformations to sketch this graph, and that is what I did. Have a good look at it, right? So this is the parent function which we translated, rather reflected and then translated. Perfect. Now let's take the next example, which is a quartic function, degree 4. It is already factored for us, so we don't have to factorize. Okay. We have to sketch the graph of the following function, indicate coordinates where the graph crosses the axis, so both x and y axis. So as far as the zeros are concerned, let's write down the zeros first. Let's write down the equation first. We have x minus 3 whole square times x plus 1 whole square. Now, the zeros are at x equals to 3 and at x equals to minus 1. The order of zeros is we have double zero at both these points. Correct? So those are the zeros at 3 and minus 1. Now let's find the y-intercept. Y-intercept means x value 0. So for that, the y value is minus 3 square times 1 square, which is 9. So y-intercept is at 9, right? Now with this, we should be in a position to sketch the graph. We have two zeros here, one at 3 and the other one is at minus 1. So let's say this is minus 1 and that point here is 3. So most of our drawings will be rough sketches, and that is what is required for this particular question. It's a degree 4 leading coefficient, let's write an, is greater than 0, and that really means that when x is approaching infinity, y approaches infinity. Since the degree is 4, right, we know degree is 4, both same side. That means end and beginning and end. So when x is approaching negative infinity, y will also approach positive infinity, same as in the previous case. So basically, the graph will be going starting from up quadrant 2 and will also land up in quadrant 1. So it's from quadrant 2 to quadrant 1. Now these zeros which we have marked are double zeros. So it is going to turn at these points. You get the idea, right? So now we can join these points and sketch the graphs. It's going to be something like this. I mean, that point is not very good. Let's redo it. Kind of like this. Is it okay? So that becomes the y-axis. So that is how the graph may look like. Perfect. So those are the turning points. In this case, the zeros at minus 1 and 3. We know the y-intercept in this case, which is going to be 9. So that is going to be the y-intercept as calculated. And clearly, we can write down the x and y-intercepts. So we say x-intercepts are at x equals to minus 1 and 3, and y-intercept is at y equals to 9. Clear? We are almost at the midway. Now let's take the second last question, which is factorize and sketch the graph of the following function. Indicate coordinate points where the curve crosses the axis. We are given the equation as y equals to 2x plus 1 times x squared minus 7x plus 6. So this quadratic equation should be factored, right? So we could write this as equal to 2x plus 1, product of 6, sum of minus 7. So that is x minus 6 times x minus 1. So what we get here is three linear factors. So let's write down the zeros first. Zeros are at x equals to minus half from the first factor, 6 and 1. So those are the three zeros. Now the leading coefficient an is 2 in this case, plus 2, right, which is greater than 0. So we have degree as 3. So it is odd degree. That means opposite ends. Correct? Greater means right up. So with that, let's try to sketch the graph. So let's say that's our y-axis. The zeros are given to us at minus half, 1 and 6. So right side is up, right? And the opposite end. So that makes sense. All are linear, so it will go from here, cross, and then there you go. So we are in a position to sketch this graph as something like this. Is that clear to you, right? So we can write down the points. This is minus half the first x-intercept, 1 is the next one, and then 6 is the third one. The y-intercept has not been calculated yet, so let's calculate the y-intercept. Y-intercept means x equals to 0. So the value of y is, when it's put x equals to 0, we get 1 times 6, which is 6. So this point here is 6. Clear? So we get the y-intercept as 6, and that is your graph. Perfect. So we have clearly marked all our points of interest. So that is kind of important in our sketching. So we are not really bothered about maximum minimum points. However, we need to indicate the coordinate points where the graph crosses the x and y axis. Is that clear to you? Perfect. Now let's take the last question here, which is the graph of y equals to ax cubed plus bx squared plus cx plus d is shown in the figure. Find the values of a, b, c, and d if the point 1, 8 lies on the graph. So this point here is given to us as 1, 8. What can we do? Well, let's write down the factored form from the given zeros. There are three linear zeros, right? We have three linear zeros. Now these are at x equals to, this point here is what? So the point here is minus 3. Each is, and this is 0, and then 2. So these are the three zeros for us. So based on these zeros, we can write down the equation as y equals to a times x plus 3 times x times x minus 2. Now to find the value of a, we could use this particular point. We know there is a point given to us at 1, 8. Substituting, we get 8 equals to a times 1 plus 3 times 1 minus 2. So x is equal to 1 and y is equal to 8. Substitute that value, right? So 8 equals to a times 3 plus 1 is 4, and that is 1. This is minus 1. So we get a value of a as 2, right, with a negative sign. 8 divided by minus 4 is a, which is minus 2. So that gives us the equation, which is, let's write down the equation here. With that, we have our equation as y equals to minus 2 x plus 3 times x minus 2. Now we need to write this in standard form. Only then we'll know the values of a, b, c and d, correct? So let's expand and write this equation in the standard form. So we get y equals to minus 2 and x times x plus 3 times x minus 2. We get x squared. Then 3 minus 2 is 1, so that is plus x. And 3 times minus 2 is minus 6. Or when you open this, you get minus 2x cubed minus 2x squared plus 12x. So that gives you the equation in standard form. Now you can compare the terms and you can say that a is equal to minus 2, b is equal to minus 2, right? B is also minus 2. So we have to see b is, yeah, we got multiplied by 2, correct. So b is also minus 2. C is equal to 12 and d is equal to 0. So those are the values. Since the equation itself is y equals to minus 2x cubed minus 2x squared plus 12x. Is that clear to you? So that is how we could actually answer all these questions. I hope you find it interesting and useful. So we began with the basic questions: how to sketch cubic and quartic functions. And then we had a very interesting question based on finding the equation standard form from the given graph. I hope it helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.